Okay, so GPT-5 is here, and I've just finished watching the hour-long, maybe hour and a half long presentation from OpenAI. And I'm going to talk about in here, not too much about just what they said, but also perhaps what they didn't say in here, which I think is really fascinating. So first off, it was a pretty cringy kind of presentation. It was very staged. It was almost like OpenAI was trying to do like an Apple presentation, except they really hadn't gotten the memo about how to do that properly. And even Sam Altman was looking off to the side as if he didn't know exactly where to look and who to talk to and things like that, which was weird, I think. I did have to have a bit of a laugh that if we look at a screenshot from where he was actually giving the presentation, you'll notice that he's got his Lego Google shoes on. So I don't know if that's a secret message after OpenAI recently inked a deal with Google to actually serve a lot of these models and to use Google's infrastructure for inference for these things. But it wasn't just Sam Altman that came across as perhaps not rehearsed or something. And I must say that I generally like the live streams where Sam Altman just sits at a table and talks to the camera and has a few other people in staff. So I kind of feel like this one actually probably would have been better to just do the whole thing like that. But as people on the internet have pointed out, they certainly didn't check a lot of the things that they put up. Here's a perfect example of one of the things that they showed. If you look at when they were showing benchmarks, they were literally showing that 52% is actually higher than 69 in here, which does seem quite strange, and that 69 and 30 are basically the same thing. So I think on X, a lot of people jumped on them about this and pointed out that this clearly isn't AGI that has arrived. And the sad thing, I think, is if they'd actually just fed their slides through GPT-5, it actually might have pointed out some of these issues to them. And that brings us to the actual model. So the whole reason we were here is it's been a long while since OpenAI has released a GPT new sort of class of models. So we had a very big jump of going from GPT-3 to GPT-4. And Sam Altman has been promising for the past couple of years that we're going to see the same kind of bump going from GPT-4 to GPT-5. Now, I got to say that from what I saw, I don't think that's the case. I got to say that from what I saw, I don't think that's the case. But I would also say that doesn't take away from this model perhaps being a really good model and perhaps taking a step forward in its abilities and stuff like that. So GPT-5 has been something that OpenAI has been working on for a long time. And when I say that, I don't just mean this model. So originally the GPT 4.5 was supposed to be GPT-5. It wasn't a big enough jump. There were lots of issues with that model, and we saw that model being deprecated from the ChatGPT, I think mostly because it was just so expensive to run. And this sort of brings us to a few things that I think that are really interesting about GPT-5 that they're not talking about too much. So the first one is that GPT-5 really, at least in ChatGPT, is a system, not just a single model. And it seems like even on the API, that is also the case. So they're definitely using a router to basically decide for each prompt or context that people are putting in, what would be the best model for this. And that means that sometimes that's going to get allocated to a deeper reasoning model for these hard problems. And sometimes it's going to be done with a really quick model. Now, you can imagine that for OpenAI, this saves them a massive amount of money on ChatGPT. So in the past, even when they had people choosing a top-end model like an O3 or something like that, if someone asked a really simple question, that would be going to the model that's using a large amount of compute. Now, that question probably could have been answered by O3 Mini or some other much smaller, much faster, much cheaper model. And here now, they're basically taking away, at least for the free tier, it does seem for the API for the big model, you're actually getting two models in there, one being a reasoning model, one being a non-reasoning model in there. Now, they talk about that you can influence this by saying, oh, think hard about this or these kind of things. But really what they're trying to do is save money on inference here. And that makes a lot of sense at the scale that they're at, where you've got 700 million people using ChatGPT. Now, the other thing that I thought was really fascinating that also points at how this is a system and not just a model was that they talk about how the model, when writing code, would often test the code and feed back to itself as it's going through this. So it does seem that there are tools under the hood that the model can actually use for a lot of these things. Now, that makes a lot of sense to do this. This means you've got like an agentic loop going on, even if you're just chatting to it in a normal way. And you can imagine that's going to be really useful for things like coding, things like mathematics, a whole bunch of different things, which are going to help this to actually do really well. And sure enough, we see that looking at a lot of the benchmarks as well. So I almost feel that like we shouldn't be calling this purely a model in here. Now, it's also interesting to see what are the things that they were promoting this model to be really good at. So we see a very big push in creative writing and expression, which again may benefit from having it as a system where it is actually planning things first and then being able to fill out those things. And in some of the examples, we did see some of the initial thinking be almost like agentic planning steps as what it's going through there. I also kind of feel that it's pretty clear that their post-training system this time has focused a lot more on creative writing and a lot more on health, etc. And this makes sense. It's not that long ago that with the frontier labs and when people were training LLMs, you would have a very small team that was doing the post-training. Now at these labs, post-training is just huge amounts of people, right? And they have sub-teams that focus on code and a sub-team that would be focusing on health and a sub-team that would be focusing on creative expression, etc. So it's not surprising to see that, okay, this has actually gotten a lot better. The thing I do think they should be commended for, though, is that this is actually an area where in the past, people were really scared to try and make these models better at health stuff because they were worried about the legal ramifications of what if it gives wrong information, if it hallucinates, that kind of thing. So I actually think good on OpenAI for actually realizing that there's a lot of people, especially in the United States, that cannot afford healthcare, etc., and around the world as well, that a lot of people basically want to use this for getting a second opinion, for being able to find out what to ask their doctor, etc. All right, so if we move on to the evaluations, the whole thing of is this a state-of-the-art model or not, I think is going to be debated quite a lot. So a lot of these benchmarks are massively oversaturated. I think I talked about this a little bit in the recent DeepThink. If you've got something where all these models are in like the 98, 99% range, that's really going to be something where you're leaving it up to chance, perhaps, for some of these. And I got to say, it's interesting which benchmarks they used and also which benchmarks they didn't use. And even on the benchmarks that they did use, things like SweBench, which is now quite a well-known benchmark, you can see that while on Twitter, some people were talking about this is actually, much better than Claude Opus's 4.1, because this is 74.9. But Graham Newbrigg, who is a professor at CMU, also one of the creators of the All Hands Agentic Coding framework that is actually fully open source and people can try out as a very cool framework. He points out that actually they didn't evaluate on 23 of the 500 instances. So actually, they've decided these 23, we could never get those. So we'll just take them out of the tests. So he's pointing out here that, okay, this is actually 71.4% in here. And so he links to the GPT-5 system card in here, where this is actually showing the details that they didn't bother to show on the main site blog or in their live presentation. And we've seen things like this in the past, where OpenAI basically had models that they claimed were very good at GSM 8K, only to admit later on that actually the GSM 8K data was in their pre-training data set when they had the ARC challenge and claimed a certain level of performance of that. And it turned out that that actually pre-trained on that. And that brings me to the ARC challenge. So the ARC Prize people have actually released scores of GPT-5, GPT-5 Mini, GPT-5 Nano to show where this actually fits in here. And you can see that while this is good, this is not the best results on AGI 1 and certainly not doing too great on AGI 2 here. This is Francois Cholet, the creator of the Art Challenge. We can see when we zoom in and look here that actually GPT-5, while being cheaper, is behind Grok 4 on the result that it's actually getting there. So that brings me to the next part, and this is the whole part around sort of speed and cost of these models. So I should point out that at least on the API, there are a number of different models that are out here. So you've got ChatGPT 5, which actually seems to be a system with two models, one being a thinking model, one being a non-thinking model, at least two that we know of. And that could actually be sort of 4 models or more in there. We have GPT-5 Mini, and then GPT-5 Nano, and then another one, ChatGPT-5 Chat Latest. So going back to the speed, clearly these models are a lot quicker. Both the speed and the cost of the models, which I'll talk about in a second, actually make me think that clearly they've got some way of using less compute. So that's definitely in part going to be the router that's going on there. But it also may be, since we just looked at the GPT OSS models, that they're actually doing things in FP4 precision. It could be that these models are actually trained in a lower precision. That would allow them to be both faster, use less compute, and therefore be a lot cheaper to run. Now, OpenAI is obviously not saying anything like that. I haven't had a chance to read the whole system card, but it certainly does seem like something is going on that's allowing them to be a lot faster in their responses and to be a lot cheaper, basically using less compute and getting more out of that compute. Now, this is a really good plus for this model system, whatever we want to call GPT-5, this sort of ecosystem. I'll call it an ecosystem of models. One of the things that you can imagine that's going to really benefit from this is coding. So we know that all these agentic tools, whether it's Cursor, whether it's Claude Code and stuff like that, the biggest challenge that you often get frustrated with is not whether the thing is actually getting it right or wrong. It's often more that just, it just takes ages to do things. And you literally see people running sort of 2 or 3 or 4 of these things at the same time on the same code base to try and get more things done. So if this ecosystem of models actually is a lot faster, suddenly having a really high quality model plus having that speed there is something that's really desired for better coding, for better agentic use, this kind of thing. And that brings us nicely into looking at the pricing of these. So the pricing is pretty amazing. And looking at the sort of model card in the pricing, we can see that the sort of big model or this sort of big multi-model system, this is basically going to be $1.25 in and $10 out. And my guess is that they've worked out that probably by far the majority of things that people are going to use it for are going to use the non-reasoning version of the model, as opposed to the reasoning part, which is obviously going to take a lot longer and perhaps be more expensive. Very interesting to see that they've gone for a context window of 400,000. This actually makes a lot of sense. I feel that while the million token context window is awesome to have, most people just never make use of that. And one of the things that they've got here, which I think is a massive plus for this, is that you can go up to 128,000 tokens out for your max output tokens. So this means you can literally put in like a whole novel and have it rewrite that novel on the fly or check the grammar, fix up parts of it, and just go through and be able to take every token in, have a sort of an equivalent token out, even if it's rewritten. This is pretty amazing. We've seen 64,000 tokens out, and we've seen the 32,000 becoming a lot more prevalent, but going to 128K out, I think is really fantastic. It is interesting that the knowledge cutoff on this, though, is October last year. So you got to think that that means a lot of the pre-training was done quite a while ago. And if we think back a while ago, Sam Altman basically mentioned that they were looking at combining the O model series plus the GPT series for GPT-5, which seems like what they've done. Perhaps they've had a very good lot of pre-training for a model, and then they've reworked that post-training to actually get this standard out here. Now, the other thing too is that while they showed off the voice and stuff, looking at it, this model doesn't support audio, supports images in, and it doesn't support the real-time API. Now, that could be because it's just coming in a new version. Maybe we're going to get GPT 5.0 in 3 months' time or something like that. But when we look at the mini model, again, we see no support for audio, no support for real-time. That said, the mini model is a really cheap deal in here. You can see we've got the mini model at 25 cents in, $2 out. We've still got the 400K in, the 128K out. But we've got a knowledge cutoff that's even earlier. So the pre-training for this one was done even before, perhaps. And then we've got the nano model, which is probably a distilled version down from that mini model with a really amazing price of 5 cents per million tokens in and 40 cents per million tokens out. So I think this price is very similar to the Gemini Flash Lite. I think it's a bit cheaper on the input from memory. Again, though, we've got no audio, we've got no real-time support in here. So you've got to think that those are going to come in the not too distant future. Now, Simon Wilson put out a really nice comparison guide. So you can see that GPT-5 is the sort of system one is coming in a lot cheaper than all the other models. We can see that this is a lot cheaper than a lot of the models that have been out there, much cheaper than Claude Opus, than even Sonnet, substantially cheaper than Sonnet. And then on par with the Gemini 2.5 Pro, as long as you're under 200,000 tokens in there. The Mini and the Nano are really impressive. That the Mini is basically cheaper than Gemini 2.5 Flash, and the Nano is coming in just below the 2.5 Flash Lite. So you can sort of see why they're planning to deprecate a lot of the GPT-4 models with this, because they kind of become irrelevant if this model is better and hugely cheaper as well. All right, so I'm going to go off and have a play with these models, run them through a bunch of tests and my own benchmarks, and see if we can get a sense of how well this generalized to real-world tasks. And we could work out how well this is going to work for coding tasks. I've already had the CEO of Cursor basically saying that this is the smartest coding model that they've ever tried. Now, I do wonder, though, is that also because it's just a hell of a lot cheaper than what they've had to pay for Claude? And Cursor's been running into a lot of problems with its users where people weren't happy with the amount of calls that they were allowed to make on Cursor to the Claude models. Anyway, overall, this definitely is an interesting release. It's a bit underwhelming. It certainly doesn't seem to have the same wow factor that GPT-4 did when it came out, and that just how much people were blown away by what that model was able to do and how it kept its lead for sort of 6 months, a year when people were trying to catch up to it. And even in the past year, people have benchmarked a lot of the open models compared to the original GPT-4 models. I do wonder, are people going to get very frustrated with the router? It was interesting that they said if you're using a paid ChatGPT, you'll still be able to pick which GPT-5 you want. But it seems to me that the GPT-5 big one is actually 2 models already. So I'm not sure how you can get it to always have reasoning. It seems like you're going to have to put that in your prompt when you go in there to actually get it to work. So I'm going to have a play with the model. I'm going to see actually how good it is for the agentic tasks, which they claim it's a lot better at. That's the thing that probably interests me most. And I've been planning to do some more videos about the Agents SDK. So I think those now I will just do with GPT-5, and we can see how it compares in those. Anyway, as always, I'd love to hear what you guys think in the comments. Please tell me if you also found the presentation to be a bit weird and cringy and a bit out there. And then also, what's your take on the model? And do you think this is going to surpass the Claude, Sonnet, and Opus for things like coding? Or in 3 days from now, is everyone just going to be back there wishing that we could get these prices for the Claude models, but still prepared to pay for that model, which they believe to be the best one for coding. All right. As always, if you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.